Welcome back, Mustangs, to another edition of No Here, No Problem. Rosenwald here with a new lesson for us today. We're going to be starting off the next unit of chapter 2 of the new book, which refers to parts of quadratics and talking about things that we've done, which is stretches and, movements, so transformations of these quadratic functions. And when we were doing these, we were doing left, right, up, down, reflections over the x-axis, reflections over the y-axis. Well, we're going to add in something new. We're going to talk about stretches. The stretches are a brand new concept for you guys. And from here, we're going to, next class, talk about stuff related to the parts of quadratics. And then from there, we will go ahead and start moving into zeros and how to solve them and how to work with them and everything related to quadratics. So today, some of the stuff is going to be kind of a review. We're going to work through about 8 problems here, and I'm going to take the problems directly from Delta Math, where your assignment's going to be, okay? So let's go ahead and get started here. I'm going to shrink myself and get myself out of the way and put me over here. So first thing we're going to be dealing with here are the properties. So remember that when we talk about f of x, and we say f of x is equal to x squared right here, this is the same thing, if you remember, as saying y is equal to x squared, okay? And what we're saying is x squared is our function. If you remember x squared as a function, this is that quadratic shape where we have a line. The graph is going to look like this. Oops, hang on, I got to delete that. Sorry, I got some stuff on here. So that's the one where the graph itself makes that U shape. That's always our parent function, is our U shape. And what we're going to be doing is taking this U shape and moving it all around to do different things with it. So if you remember, the first thing to talk about here is when we have this a value, okay? This a value right here is talking about a shift in our graph. The first shift we talked about is when the graph moves up a, okay? When we have a minus a value in front of this, we say that it's a shift down a. When we have a minus a on the inside here, if we see the minus sign right here, remember that we mean that we're going to take this minus a and do the opposite of it. So if we see like a negative 3, we're going to go positive 3. And so what that translates into is a right 3, or right a. When we see a plus a inside of the parentheses, again, these two right here we're talking about inside the parentheses, okay, versus the other two, which were outside. So again, when we look at these are outside. And when we look at these are in, okay? So those a values are inside the parentheses versus outside the parentheses. When we have an a value inside that says a plus a, that actually goes the opposite direction. It's going to make it go to the left a, okay? When we say negative f of x right here, what we're saying is, really think about this. F of x is the same as the y value. So what we're saying is, let's take the opposite y value. So if we think about any coordinate, like let's say I had a point right here and I look at the y value is right here at 4, right? So if I took that 4 and I said, well, let's do the opposite of this 4, I'm going to take this 4 and I'm going to go ahead and go down 4 instead. And that, you see how it reflects over. So instead of being at a positive 4, I take the opposite 4 and it makes it a negative 4. And you can see what happened was we actually took this graph and we went over the x-axis. So this is a reflection over the x-axis, okay? If I took and did the opposite x, the f of negative x, which is right here, okay? This right here is saying take the opposite x value. When it's inside, it's saying take the opposite x value. And so what that means is that if I look at this coordinate right here, you look at the x value right there, which is at 2. Well, if I said instead of going to a positive 2, let's go over to a negative 2, I would take this value that's right here and I would drag it over. Well, this activity doesn't allow us to drag it. But what happened is I would take this point and actually reflect it over to this side, reflecting it over, back and forth, going this way. And by doing that reflection, what I'm doing is I'm reflecting over the y-axis right here. So that's a reflection over y, okay? The last transformations that we have to deal with here are going to be the a times f of x, which this one is unique. What we're saying is that if I have a value outside of my function, we're going to go ahead and do a vertical stretch. So that means take whatever your y value is, and you're going to multiply it by that value that's outside of there. So let's say that I had like a 2 right here. What it's saying is whatever your y value is, multiply it by 2. So if I look right here, I'm at a 1. If I take that and I multiply it by 2, well, 1 times 2 is going to equal a 2, and it pulls it up. And you can see what's happening is my graph gets stretched upwards, okay? It's like if I took these points and I pull them upwards, I'm stretching it in the upwards direction here, okay? And you can see it causes it to look like it shrinks inwards. If I had a value where, I don't know what happened there while I've got this, but if I had a value right here, which is absolute value of a is less than 1, what I'm saying is this a value ends up being a fraction which is less than 1. So what that's saying is that whatever your y value is, so in this case, let's take this 4, and if it says half in front of it, what I'm going to do is I'm going to take half of this y value. Well, if this y value is at 4, half of that is going to bring it down to 2. And you can see that what it's doing is it's getting shorter. It's getting actually pulled down in this direction, and that's called a horizontal shrink. Okay, I'm sorry, vertical shrink. Okay, and then the last one, that f of ax, that's one we're going to save for another time. We'll worry about that later. Okay, but let's dive into these. Before we do these, though, I'm going to recommend that when you guys are doing these, the best thing you could probably do is when you're doing this, do the stretches first, and then do all the movements. Always stretch before you move it all, okay? Think of it like exercise. Always do stretches before you move it all, okay? Sounds good enough? Like, do stretches before you actually do some exercises. So let's take a look at this one. So we see right here that says there's a 6 right here on the outside, and then there's an x minus 5 squared. So let's write this down. We have f of, this is number 1, f of x is equal to 6 times x minus 5 squared. So we have two transformations going on in this one. We have a 6 in front of that f of x, okay? And then we have an f of x minus 5, okay? So those are the two transformations there. We got the 6 from in front of there. And then we've got that minus 5, and you can see it's actually inside of my parentheses, so it's right here. So when we look at this, let's go back to our transformations here. You can see them up above, but you guys can look back at your notes. This right here, that first one says we're going to vertically stretch by 6, okay? That's the first thing we're going to do. And then, and that's because of this 6 that's right here, okay? The second thing that we're going to be doing is this minus 5 that's right here. That's going to cause us, if you remember, to do a movement to the right. So we're going to go to the right 5. Okay, so let's go through and do the order that we just said, okay? Start over on this. I'm going to go ahead and move this up so we can reset it. Okay, it resets, and what we're going to do is we're going to follow the instructions here. We're going to go ahead and vertically stretch by 6. So what that means is let's take an easy point right here. Let's take this one, which is at a 1. That 1 right there, if I take that and say, let's take that 1 and multiply it by 6, that means we're going to take 1 times 6, which is now 6. And so I'm going to pull this 1 all the way up to 6. Okay? So again, that 1, we said let's take that 1 for the y value. My coordinate right here is at 1, 1. You can see that coordinate right there is at, we'll use this one, sorry, 1, 1. If I say 6 f of x, I'm saying take that y value and multiply it by 6. So that y value is going to become 1, 6 because I'm multiplying the y value by 6. So if I take this, I'm going to stretch it up to 6. We're going to be right there. Okay, that's that value. Now, the second part of this is we're going to take our graph and we're going to shift it to the right 5. So now let's take this point right here, that green point, and let's shift it to the right 5. That's it. And there's our new graph. Okay, so let's go ahead and submit this. If I can. All right, we see we got that right. Let's go to the next one here. Okay, let's do our new problem. All right, so this one, number 2, we have y is equal to negative 5x squared. Okay, so we have two changes that are taking place in this one. What's going to happen is we have a negative in front of my function, and we have a 5 in front of my function. Okay, so we have two different things there. We have a negative in front of the function, and we have a 5 in front of the function. That negative, when we look at it, is going to cause a reflection over x. And then that 5 is going to be a vertical stretch by 5. Okay, that value 5 is bigger than 1. So let's go ahead and do these two movements here. Okay, we're going to go ahead and take it and reflect over x. So it allows us to do that right there. So let's go and reflect it. I don't know if it does it for us or not. So there, you see it does it for us, so that it's nice and easy. And then we're going to go ahead and it says we're going to stretch it by 5. So we're going to take this y value that's right here and we're going to multiply it by 5. So instead of being at -1, we're going to go ahead and do -1 times 5. So -1 times 5 is -5. So we're going to stretch this out by 5. Okay, let's go ahead and submit that. Okay, let's go to our next problem here. Go to a new problem. All right. This next problem, we're going to have f of x is equal to x minus 4 squared. That problem right there, we're going to go ahead and shift it to the right 4. That's the only thing that's going to take place. We have f of x minus 4, which as we know is to the right 4. All right. So we'll go ahead and take this and we're going to go to the right 4 with it. So unfortunately, I have to do a stretch first. I only do that because the programming makes it so hard to actually grab this button that's right here first. So I'm going to go ahead and move it to the right 4. I always recommend you do the stretches first, even if you don't need it, and then put it back. And then this one is 1 away, like it usually is, 1 up and 1 over from there. I don't know, the programming really struggles with grabbing that button unless it's those red buttons are pulled away from it. So it is what it is. All right, let's go ahead and check that. Okay, let's go to a new Oops, oopsie doodle. All right, so let's go to another one. I don't like that one. Let's do this one, number 4. So we have y is equal to 1/2 x plus 5 squared. So we have two transformations going on. We have that half that's in front of my function, right? You guys see that half there. And then we have this x plus 5 that's a part of my function. So the two transformations here, when we look at this, that first one is going to be a vertical shrink by half. Because what's happening is, what we're saying is we're going to take that y value that's there, so whatever the y value is in the problem, and we're going to take half of it. So we're going to take these y values and we're going to go halfway down with them. And then the second thing that we're going to have here is this plus 5. That plus 5 means we're going to go left 5. So remember, let's go ahead and do our stretches before we move, okay? So let's go to our graph here, all right? And we are going to go ahead and do a vertical shrink by half. So that means let's take my y value right here, and I'm going to go half of what it is. So this 4 that's right here, what's half of 4? That's going to move it down to a 2, okay? Now we're going to go ahead and do what it said, which is to move the graph to the left 5. Right, I'm going to struggle with this. I need to get this out of the way first, sorry. So I'm going to go to left 5, and then we're going to go back to where that was before. So we said it was right here. That's the original graph. I'm going to go ahead and move it half of 4, which is down to 2. Okay, this is that annoying problem where those red dots are just in the way, and that's why I had to move them first so that I can move it to the left. Okay, all right, let's go to a new problem here. Okay, and we're going to number 5. Number 5 says we have y is equal to 3 times x plus 5 squared. And so we have two transformations in this one. We have 3 times f of x. Okay, and then we have f of x plus 5. So this is going to be a vertical stretch by 3. And then this is going to go left 5. Okay, so let's go ahead and do those changes. We're going to go ahead and we're going to do a vertical stretch by 3, and then we're going to move it to left 5. So vertical stretch by 3 means that if I was to use this point, all right, which that y value is at 1, what is 3 times 1? That's going to be equal to a 3. Now, why did I choose that point to use instead of the other one? Well, if I'm at a 4 right here, for this point, what's 4 times 3? Well, that one's equal to 12, and you notice that my graph only goes up to 10 here. So I didn't choose that one because it would have gone right off the graph. But I could use this point right here. What's 3 times 1? It's going to be equal to 3. So I'm going to go up to 3 now, because 3 times 1 is equal to 3. Okay. And then we're going to go ahead and do what the graph says, which is to shift to the left 5. So I'm going to grab this and we're going to go left 5. Okay. All right, let's go ahead and submit that. And I think like maybe 3 more problems. So does that sound good? We'll do like 3 more practice problems, make sure we really understand this concept. All right, so we got 2 transformations on this one. Okay. So we've got number 6, we got y is equal to x minus 4 squared plus 5. So we have f of x minus 4, that's that minus 4 that's in the parentheses there. And then we have f of x and plus 5. That's that 5 that's outside of there. So we got this minus 4, and then we got this plus 5. This means we're going to go right 4, and this means we're going to go up 5. Okay? No stretches or shrinks in this one, so let's go ahead and do exactly what this says. We're going to go right 4 and up 5. I'm going to get these points out of the way. I'll put them back here shortly, but let's go ahead and move it to the right 4 and then up 5. Okay, and unfortunately I actually moved those points a little too far. Let me reset that. I moved them way out of the way there. Okay. So these points, I'm going to move them. I just got to move them a little bit so I can work with this. We're going to go right 4 and then up 5. And then there were no stretches or shrinks, so I'm going to move this one back to where it was, which is 1 up and 1 over from that green point right there. Then 1 up and 1 over. Let's go ahead and check it. Okay. All right, we got a couple more here, 2 more. Let's find a good one. Let's find a real good one. Oh, this is a good one. I like this one. So we're going to go for number 7. We're going to go f of x, or y is equal to 1/2 x minus 5 squared. So we get that half f of x, and then we have f of x minus 5. Okay. So in this one, we're saying half of the y value, which means this is going to be a vertical shrink by 1/2. Okay, whoops. By 1/2, and then it's going to move to the right 5. All right, so let's go ahead and do those transformations there. So we're going to go ahead and vertically shrink it by half. Problem is that if I take these points and I move them down, I'm bringing them closer to that green. So I'm going to move them out of the green for a minute, and I'll put them back. But let's go to the right 5. Okay, so we'll go right 5. Now I'm going to put this back to where it was, which was 1 up and 1 over from there. And then we're going to take this y value, whatever the y value is, we're going to go ahead and cut it in half. So this 4 that's right here, we're going to do half of it, which will bring me down to 2. Okay, and that is it on that one. Okay, and let's do just one more question for practice here. New problem. Let's find a real good one. I don't like that one. I don't like that one. Don't like that one. We just did halves. Oh, there's got to be a good one here. I saw it earlier, and let's see if I can get it back. Oh, this is a great one. Let's go. This is exactly what I wanted to end on. All right, so for number 8 here, we're going to have y is equal to 5 over 2 x squared minus 2. Okay, so we have 2 transformations going on. We have 5 over 2 f of x, and then we have f of x, and that minus 2 that's outside of the parentheses. Okay, so this one we know should be down 2. That's an easy one. Now that 5 over 2, when we look at this, 5 divided by 2 is equal to 2.5. So what that is saying is that if we go back to the beginning of our notes here, you can see that that 2.5 is bigger than 1, right? 2.5 is greater than 1, which means that this is going to be a vertical stretch by 2.5. So let's go back to that. So this is a vertical stretch by 5 over 2 or 2.5, either way. Okay, so now let's go to our graph here. All right, we're going to take this and we're going to take it and vertically stretch it by 2.5 times what it is. All right, so if I go 2.5 times 4, well, double 4 is 8. Okay, and then half of 4 is equal to 2 more, which would put it up here. Okay, another way you can look at this as this 1 that was right here, you see where it's at 2.5 right here? It's at 2.5 right there. Now, if I had started at 1, what's 1 times 2.5? Well, 1 times 2.5 is just 2.5, so I put it right here. And you can see it matches that other one, which just went up to 10, okay? Now we're going to take this and we're going to shift it down 2. So let's grab this vertex and drag it down 2. And there's your equation, or I'm sorry, your picture, okay? Let's go and submit that. Yes. And we are done. So for right now, we're trying to keep this as easy as possible. We just got the reflections, left, right, up, down. But now you know how to do vertical stretches and shrinks when we're talking about affecting the Y value. Next class, what we'll do is we'll work on the horizontal stretches and shrinks, okay? Until then, you guys take care, be safe, be respectful, be responsible. Do your assignment that is going to be assigned to you guys for this, and then don't forget to submit it when you're done, okay? Take care.